My name is James Hines. I'm the Spacecraft Project Manager working for EADS Astrium for the hylas 1 spacecraft. hylas 1 was built and designed by two companies. First of all, Astrium in Europe and also the Indian Space Research Organisation. It was built for a European customer called Avanti Communications, and they will use this spacecraft to provide broadband access, fast broadband to rural European areas. So here you actually have what we call the reflectors, and the reflectors are used to provide that broadband access, and they're shaped in a particular manner so you can actually send a signal directly down to Europe. hylas, it stands for Highly Adaptable Spacecraft. It gives the operator the ability to change the configuration of the payload in orbit. Behind us we have 3 engineers who actually went out to India to work on the hylas payload and also supported it here in Portsmouth. For Avanti Communications, if they have a particular change in demand, it peaks up in one European area but down in another area, they can actually adapt the spacecraft to accommodate that in real time. There are 3 panels you typically use on a payload, and this panel behind me just shows the typical complexity of one of those payload panels. Remember, we have 3 of them on each of our spacecraft. When you actually launch the spacecraft, you obviously want it to be very compact. These array panels will be folded against the spacecraft body during the launch, but as soon as you get onto station, you actually have to deploy these panels so they can start generating the electrical power that you need. The other half of the spacecraft which supports the payload is the platform, and the platform has got all of those life support functions, the thrusters, the brains knowing where the spacecraft is, the power using the panels and the battery. The space is a harsh environment. You've got temperature extremes, you have the whole problem of being in a vacuum. So when we are actually in India, we had to test the whole of the spacecraft vehicle very comprehensively over all of those environments to make sure that when we actually deploy on orbit that we have complete reliability and trust. It's going to operate for 15 years, which is the mission life of the spacecraft. This is where hylas was built, and this is where we tested the payload. After the Ariane 5 rocket has launched hylas into a transfer orbit, the spacecraft itself then also has to adjust that orbit. So we have the propulsion system on the spacecraft, and that's used to actually position the spacecraft in its final orbit and keep it there. It's got various components. You have tanks. This particular one is used to hold the pressurant, and then we have various rockets which are here and here. So the work involved in bringing a hylas 1 spacecraft together is very interesting. And what makes it all the more interesting is working with a great group of people in many different countries. Today I want to introduce you to one of the key people who's helped bring this spacecraft together.
My name's Alan Evans. I was able to work on this programme from Portsmouth all the way through Bangalore and then finally onto the launch campaign in French Guiana. An incredibly enjoyable experience, proving how important teamwork is on a programme like this.
So I hope that you've seen, as we've walked around, just some of the things which make this business exciting and why it's absolutely captivated me for 20 years.